Hey everybody, welcome back to this very special episode of Construction Sunday. Today we're going to be talking about the evolution of construction, the history, the future, and the current innovations that really drive the industry forward. But if you wouldn't mind hitting that like button and subscribing to my channel before we get started, that would be great. Now, into today's video. So, what are we looking at when we look at the last 100 years of innovation? So, there's a couple things. So, the first thing we look at is how people did things, right? So, over in Europe, up until about the turn of the century, people were still using stone. It was common practice to use structural materials such as cement, rocks, bricks, and other forms of masonry. There were timber frame structures, Tudor style homes, but usually how those were built were a series of rough, raw hewn timbers, and then in between they would take lattices and then plaster and then cover them. And prior to plaster, they would use mud or clay. So, you know, it works. It works as a great insulator, and it is strong and durable. However, maintenance. Maintenance is a big thing, right? You look at how much work it is to upkeep an actual Tudor home. There's a lot of Tudor revivals over here in the US, but a lot of those homes are made with synthetic materials or materials that can be painted. So, with that in mind, let's talk about some of the innovations going forward from there, leading up to today. So, we look back at how our country was founded. We're a bunch of immigrants, we're a bunch of people trying to start something new. The colonies did some really incredible things. They instilled great values. Some of them still plague us today, for better or for worse. And the other things that they did that were just absolutely phenomenal were, just their level of craftsmanship. They came here with nothing. But for the time being, let's talk about how we got from the Tudor style home to the technology of today. Trusses are an amazing stepping stone. As people around the 1700s were stick framing their homes, they had some odd complications because your home was either built out of brick or they would use a combination of brick and timber styled framing. Now, timber style framing allows you to go further distances before you have another member that makes up a structural wall. That can lead to less material usage. However, that adds more time because that means every single timber, every single piece of wood you put into place not only has to be jointed, but it also has to be milled and trimmed down on site. And a lot of times as these buildings are getting erected, especially the farmhouses from the mid 1700s, especially around the time of the Revolution, no one used floor plans. They had their methods for making things square and symmetrical, but they were going based off of methods and technologies that they had existing coming from Europe. So, timber framing, it's efficient, great. The next thing that we started to see was more brick buildings. We weren't the first ones to invent them, Europeans did that well before we did. But the one thing that the Europeans gave us was an unfair advantage where we had an abundance of clay and other minerals so that way we could make really strong bricks. And because a lot of people knew masons, it was very easy for people to get these raw materials and build kilns on their own properties. It's really cool to go out east around Washington, D.C., and maybe even further north into upstate New York, and look at all of the cool old farmhouses. Because when they did use brick, oh man, they really took the time to make sure things were done right. So, in order to give a little bit more context here, typically how it was done is that you would have kiln dried bricks on the outside. That was the structural integrity of your home. On the inside walls, they would use sun-dried bricks. Basically, as soon as they get wet, they turn back into clay. But they're dry. They're dried by the sun, and they work great as an insulator, and it's a great architectural way of not having to frame anything or use any wood at all. So a lot of times, especially in Europe, during World War II, you can see a lot of burnt out shells of homes, and that's because they were either built out of stone or when they were built with brick, the bricks were strong enough to withhold all of this. And the crazier part for Europe is during things like the Blitzkrieg, anything that was built out of brick actually accidentally got kiln dried instead of sun dried. So these are all, like I said, technologies that Europeans had developed. And they were developed so that way you could go higher with your structure. And they were also developed so that way you had something a little bit more rigid, something that didn't tend to rot as fast. It's very fascinating because if you look at what led up to modern framing, a lot of it was based off of Tudor-style structures. They took the ideas of the cross members, right? You had your verticals, and then instead of going horizontal, they would have these angled pieces that would go in between these beams or in between these posts. They'd have their beams at the top, and then they would tie in with different lattices and butt joints in order to make sure that they were really tight with all of that friction so that they wouldn't move during windstorms. And then they would use pegs, and then in later years they started using nails. So we look at all of those different things as small innovations moving things forward. Let's come back over to the States, where we started innovating with timbers. Well, it wasn't fast enough. If you go to some of the homes, especially down in the South, a lot of them started using techniques that they were learning about from Native Americans, and they were using adobe-styled structures. It didn't get really popular out east. It was more of a Midwest and Western thing that was really, really popular because the less moisture they have, the less issue you will have with the structure turning back into mud and sticks, right? Because you need all of those twigs intertwined with each other in order to apply the mud and the clay for it to make that weatherproof seal. And the more moisture you have, that's problematic. There is a ton of rain out in the Midwest and on the East Coast of the United States. And so because of that, adobe structures don't work very well. So what are you to do? If the West, they can build these structures really fast and everything else is, it's fine, it's strong, it'll work, but it's not efficient. So they started coming up with ideas. Enter in stick framing. They found that if you used a piece of dimensional lumber, right, something like a 2x4, something that could be manufactured, you could assemble these homes a lot faster, and they would be almost as strong as a timber-framed home. So moving forward, that's what they started to implement. And then as homes started getting built faster and faster, new ways of doing things got pushed forward. You had combination homes where they would use the kiln-dried bricks on the outside, sun-dried bricks on the interior walls on the exterior, and then they would use structural timber-framed or stick-framed walls on the inside. Then you got to stick-framed roofs instead of timber-framed roofs. It was faster, it was more efficient, you were using less material, you could do more with less people, you didn't have to have any special equipment, and it wasn't unwieldy to assemble your own home. It was very reasonable for one person to do most of the work, especially in the early 1900s. Let's go forward again. Enter in the nail plate. The nail plate is such a simple invention, and an engineer was looking at ways of simplifying the way we did roofs, because we were trying to build these homes. We had a little bit of a housing shortage, especially after World War II, and things were getting a little hectic, right? You don't have enough manpower to build all of these homes, especially when it came to the stick-framed roofs. So we skipped, a century worth of timber framing and went to stick framing. We went from stick framing to being able to manufacture trusses. The nail plate did a lot for construction because for the first time ever, you were able to get a piece of equipment cheaper than labor. Now we're getting somewhere, right? So now we're cutting out workers and people stick framing roofs and having the craft and patience to do it. And the other problem that nail plate solved was that these roofs were stronger because of the way they're designed and how these pins dig into the wood and they get pressed together with a hydraulic press, right? This is all made in a factory. And then when they get shipped out, they get bundled together, get labeled, so that way you follow the floor plan and the series of architectural prints that have all of those types of dimensions and labels. And as you follow through on all of those things, you end up with a completed home. OSB and plywood are crazy innovations for construction. Prior to plywood, we were using wood slats. These could have been from any type of tree, any type, and usually it was just pine and poplar, but they would mill these. They were all sorts of widths. It didn't really matter as long as your home got covered, right? And so if you had a stick-framed home and you wanted wood siding, what they would do is in the early days, they just used wood slat siding. Well, as an innovation, instead of just using wood slat siding, they would use thin wood slats to go up the stick frame structure and then put wood slats on top of them. Once painted, incredibly waterproof, problem solved. Kind of. Things got a little bit more complicated. Wood rots, it grows moss, and once the lichen is there, you also start to attract our pesky little friends that like to help things decompose. Enter in the termite. So how do you fix these problems? Well, you can manufacture a product that's a little bit more resilient. Now you have plywood. Plywood is laminated sheets of wood with finished grade materials. Typically, you'll have a veneer on the outside of a premium wood such as oak, maple, any of those other hardwoods, sometimes even things like mahogany or purple heart. So all of these different plywoods start getting produced, and it also expedites the process. We're talking raw, rough, structural material, not so much architectural stuff that's designed for beautiful things, right? We're talking, the ugly stuff, the stuff that's made out of pine, usually. Like I said, once again, they started using whatever wood they could use. Sometimes it was poplar and pine together. And it was great because these trees were plentiful, they grew quick, you were able to go alternating directions, increasing a thin piece of wood's strength by almost 9-fold, which is really impressive. One sheet of wood used to be able to only hold up to maybe 75 pounds if it was an inch thick. While at 3/4 of an inch thick and a sheet of plywood supported every 18 inches, sometimes 24, was more than enough. It was so strong that you didn't have any bows in the floor. It was easier to install, and like traditional slat flooring and siding, some of these materials had a tongue and a groove, so that way you could line this up evenly and get a really tight fit. Great innovation. It sped up home building immensely. We went from being able to build a home in around 18 months to being able to build a home in as fast as about 8. And make sure that in those 8 months, right, that the home is built not only structurally well, but also make sure that the materials we use are not faulty. We started looking at some of these other developments. We had the innovation of weatherproofing. we now have a way to keep the moisture off of all of the wood structures we're erecting. This is great. Now we need different siding. So let's start talking about the last decade or so and now and some of these innovations. The reason why I wanted to do this video in the first place is because there is so much information. One of the crazy things out there is that you can look at individual licenses. Now, with individual licenses, you do have to keep in mind when you're checking someone's license to not dox anybody. There's no address on there, but there is a name and a phone number typically associated with that information. So let's talk about some of the things here. So in 2001, in one of my other videos, I talked about the death of craftsmanship, why things are falling apart. Go ahead and check it out here if you haven't had a chance to do so already. So talking about today and 2001. So in 2001, there were little over 2 million people living in the state of Utah. Today, there are around 3.2 million people living here. Because of all of this growth and everything we've been able to do, we've only had, 1.1 million people increase since 2001, which is crazy. So we look at all of the changes that are taking place. In 2001, there were approximately 8,700 apprentices enrolled in trade programs every year. In 2024, we found that most people enrolled in trade programs, especially like the apprenticeships for electrical, we only found around 8,900 people enrolled. So let's talk about some of these other variables here and talk about the future. So some of the crazy things with these numbers I'm going to share, they're not there to deter anybody per se who wants to enter the trade. I think we need more people. If anything, these numbers are going to tell you that we have to have more young people, and this is great. So one of the things that I looked at was how many people have entered the trades, how many people have their contractor's license. So I started with individual contractor licenses and what number of those contractor licenses have businesses associated with that license. In the state of Utah for 2025, there are currently 547 registered electrical contractors with the Department of Professional Licensing, or DOPL. This is crazy because you would think, okay, that number needs to be a little bit higher, because that means that for every almost 100,000 people, there is one company to service you. That's not great. And so next we looked at how many tradesmen, period, there are per portion of the trade. So one of the things I saw was that if you have numbers stagnating for the most part, we have seen a net decrease in the amount of electricians per Utah resident. So circa 2001, you had around 34 people per Utah resident. Fast forward to 2024 that we have numbers for, it shows that we have about 24 people per Utah resident. That is not a good number because that means we've had about a 30% decrease in enrollment. That's just what the numbers show. That's not even showing people exiting the trade, right? And as mentioned in some of my other videos, I've seen so many young people enter the trade. A lot of them stay, which is great. But when you have 3 out of 10 people who enroll in a trade program leave to go to a different career, you end up with a huge shortfall. And this is something I really want to drive home. Utah is about ready to host the 2034 Winter Olympics. That's a decade away, right? But you have to really think about how much work that's going to take. And after 2002, we had a huge building boom, we also had a immensely massive influx of people. We haven't stopped. For the last 17 years, the state legislature has proudly stated that the hottest job market in the entire country of the United States of America is Salt Lake City, Utah. Let's think about that for a minute. A state with less than 4 million people has the hottest job market in the entire country. The amazing thing about this, that means that there's opportunity everywhere, and we need young people to get involved. So let's talk about some of these opportunities for young people, shall we? There are some new innovations coming into the workplace, so let's talk about those. So, with the advent of all of the things that have come before, between trusses, stick framing, and the innovation of cellophane blocks and things like that that allow us to do foundation work, and all of those types of things a lot more efficiently. So, looking at current innovations, what do we have? We have not just concrete. We also have an amazing opportunity with companies like GoBlocks. GoBlocks is a really cool company. There's a couple others, but GoBlocks is really cool because they use propylene and other recycled materials with OSB. The reason why that is such a huge deal is that it enables people to build all of these homes, and not just a single-story home, right? 3D printed homes are amazing because it enables people to, have a company come out, use concrete and all of these really amazing products to give you a single-floor home. But that is about all it's good for. You can do a 2-story, sure, but you might have to do some other structural framing on the inside of your home, or steel, right? And if we know anything about steel, is it's not cheap. There are some companies out of Tooele in Utah that have done exactly that. They've mastered the art of 3D printing homes, and they are really, really good at what they do. I'm looking at all of these large apartments that are going up. I really do believe that we need more condos more than we need apartments, because apartments are going empty, because by and large people still want to own here. One of the crazy things that I've heard is that, Gen Z and millennials don't want to rent. Well, if you follow the trends over the last 30 years, you really, it makes no sense to me, because compared to 1980, we've gone from about a decent apartment that you could rent for $250 a month all the way up to about, $2,000 a month for a decent place to live. And now you're, looking at, you might be able to find a 2-bedroom, 2-bath in downtown Salt Lake for around $2,400-$2,500 a month. But that's not even great, because if your income is only $80,000 a year, yeah, you might have some conveniences, but you're not going to have a lot of play money left over, especially after taxes and everything else you have to pay for. Cars and everything else. So let's ignore that for a minute, shall we? We have a huge shortfall of electricians, specifically electricians, because that's the industry I came from. But as a whole, the trades are losing people. Now, there's the argument that Gen Z and millennials don't want to work anymore, but I think the solutions are right in front of our face. Why work harder than you have to when you have something that is going to change the landscape, that can really help not only move these projects a lot faster along, but on the backside of that, you have something really amazing happening, right? You have different electrical technologies that are just constantly coming out of the woodwork. Innovation in the electrical field for equipment and distribution, lighting, outlets, light switches, all of it is immense. There's so much innovation, and it's occurring so quick, it's hard to keep up with. It's one thing after another. You used to have to worry about structural things. Now you have cut-in fan boxes. Now you have this. Now you have that. Granted, some of these things existed before, but they've been improved upon so many times that, different pieces of material that we would rely on for remodeling a project, we don't really have to rely on that much anymore. With the advent of the plastic box, we don't really have to rely on a metal cut-in box anymore. It's a wonderful, wonderful development. Now let's keep going. We have more and more and more things going on. We're able to pull wire faster. We have new color coding. That just got rolled out last year. All of the wires are changing colors depending on whether it's a 2-wire or a 3-wire roll. All of these things are going to help people expedite the process of pulling wire. And now it gives fuel for inspectors because now they know what to look for. They can nitpick now. They can nickel and dime you too. So with that being said, you now have all of those going on. So let's talk about some of the other crazy things that are going on that are leading us up to these crucial moments. So some of the things we need to talk about are what does the future even hold? Utah is a ever-changing place, and I can think back to when I was a kid when streets like 114th South didn't exist. I remember a house in South Jordan called the Half House, and they were asked back in the mid-1900s to stop building because they were going to build a road through there, and they never did until like 2013. Maybe it was 2014. I'll put whatever caption there, just to give you an accurate number. But there's so many crazy things happening that just blow your mind that it's unreal. In 30 years, I've watched Salt Lake go from a mere 1.8, 1.9 million people to over 3 million people in almost no time at all. That is nothing short of astounding. A state with ample resources when it comes to minerals, but one of our biggest resources that we're short on is water. And as we continue to grow, we're going to need to rely on these innovations, not just for building homes, but for how we do things. We can learn from a lot of places that are in deserts. We are one of the driest states in the country. And, in fact, we are the second driest state in the country, only behind one. Any guesses? Well, if you guessed Nevada, you'd be correct. We are a very dry place with very few opportunities of having water at all. And so with innovation comes change, and with change comes adaptability. And, there's a lot of scary things, especially when change happens this fast, right? Everyone's got a different opinion on how things can be done and how to do things. But one of the things I think we can all agree on is that doing nothing and not embracing the future technologies that we're developing, they're not going to do us any favors. Artificial intelligence may be the biggest saving grace for the trades and construction workers. Why do I say that? People say, oh, well, robots can build a house. But I don't think people realize artificial intelligence can only go so far. We are the ones who are the architects for artificial intelligence, and it can only go as far as we tell it to. When building a structure or a home, we can use artificial intelligence to help us find ways to save money, save time, and we can also use it to find new ways to cut down on certain expenses that otherwise we would have just wasted our money on. Think about being a business owner. There's always something, right? I can't tell you how many times I've seen small business owners struggle because they gave a bid, they got the job, now they're almost at budget. And once they exceed budget, they start losing. You don't want to lose money, especially when you're halfway through a project. It gets really scary. How many times do you have to go to Home Depot for you to be in the red? The answer is only twice. I know that seems very low, but it's the truth. If you have a plumbing issue, that plumbing issue could be as cheap as 50 cents. But if it's a big issue, you get your excavator there, you get the parts and everything, and now you just spent $10,000. That could be the difference between being able to have a nice cushion to being out of money. Artificial intelligence is great at analyzing situations in which there are so many variables, because the one thing it can give us that regular insight from people can't, the one thing it can give us is perspective, right? It can show us the silver lining that we would have overlooked in something else. So if we look at some of these other things that we can look forward over the next 100 years, isn't just artificial intelligence. We can look forward to 3D printed homes. Imagine a skyscraper that's 3D printed. I know it sounds crazy, right? Steel is one of the greatest innovations of our age because it enables us to not only shoot rockets up into space, but it is so strong and malleable that we're able to form it into whatever we want it to. The other issue you find with steel, or one of the issues you find with steel is that it corrodes. Well, when you 3D print something, you're dealing with concrete and composite materials. The problem with concrete is it's too rigid, right? If an earthquake strikes a building that is, let's say, 6 stories tall made out of solid concrete, you're going to end up with a very rigid structure. If it's only concrete, right? Most concrete buildings are not just concrete. It's rebar, it's other things, PT cables, all sorts of stuff. But just concrete will crumble. Why? Because it's dense, it's heavy, and it's brittle. With enough force with enough force from the earth, it can shatter an entire building like it was glass. It's truly crazy what's happening, and I'm sure people have seen a lot of the earthquakes that have just obliterated Asia recently. It's truly devastating, but the one thing we can learn from that is how can Utah learn and evolve from those types of structures, because we are in a very earthquake prone, or historically very earthquake prone area. And so we really can look at all of these different developments to help us become better at what we do. And so what do you guys think? Do you think that AI, 3D printing can be our saving grace? Or do you think the solution is something more like Goat blocks? What do you think? Put your thoughts and comments down below. I'd be interested to know. And until next time, this has been my Coffee Corner, and I'll catch you on the next one.